Hello my friends, this is part 2 of Astronomy for Astrologers, and what we're learning about is how the planets actually move through the sky. And in order to get an idea of how they move through the sky, we need to look at an image of the sky. And here's an image. This is a rather simple one. There are some planetarium programs that are a little more visually appealing. The Stellarium program is a great free planetarium program. But I'm using this feature in Series 1.3 because it enables me to relate it to the astrology chart wheel and move things forwards and backwards in ways that makes it easier for me to explain. Now, what we've been learning is how the planets all rise in the east, set about a half a day later, and then this image here on the right is the sky below us, and they would set and then come back up here and then rise again. This is like two halves of a ball, and you could slide this image on the right to the left and to make a whole ball, like a basketball or a baseball or a soccer ball. You could slide this to the left. Underneath this is protruding out, and this is protruding down is the bottom half, and put it together, and that's the whole celestial sphere. So as the planets move through the sky, as the sun here has already risen, how do I know it's risen? Because it's on the left side. Remember, this image on the left side is above the horizon. Here's the sun, it's on this side, means it's up here. If I go an hour later, it's moved up in this direction. So it's moved from here to here, and an hour later it's moved here. It's making an arc like this. It'll actually make an arc that's parallel to this yellow one as it travels through the day. Let me show you that. See where the sun is just after sunrise? Well, we don't have this yellow continuing here, but at a certain distance it's going to travel about in a path like this, up, and this yellow line, called the Celestial Equator, will not change, and during the day it'll travel up parallel. It'll be parallel to this yellow line. It'll travel in a band, about up, let's see, it should go right through Orion, maybe in about here somewhere, and then back around through this part of Andromeda, and then back down here. Let's see if I'm right. The ecliptic plane will wave all over the place, but the sun will make this nice, it's like a car going around a racetrack, or somebody running around a racetrack, and this is a path, and they're going to run in a parallel path, like so. Let's see if I'm right. I hope I'm right. Okay, go an hour, 2 hours, 3 hours, and it's following this path about this distance from the ecliptic plane. I'm going to go an hour later. Here's the sun. An hour later, an hour later, an hour later. So it's following this path about like this. And it should come down here, maybe, based on that distance, I guess a little bit above, right in here. So we'll follow it around. The stars are moving, so everything's moving. And you see it's kept that same distance. So it's in this racetrack going just like that. It's the top of this thing about that distance apart, which is about 15 degrees. It's about 15 degrees because each one of these bands is 15 degrees. 15, 30, 45, 60, 75, 90. So it's traveling in a band through the day about 15 degrees from the yellow line. And I go back, I'm going back, back, back. Here it is, here's the sun. And back, 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 back. So, as it travels, the distance from the horizon changes, and that distance from the horizon is called the altitude. Okay? We also use the word altitude, like the altitude of a mountain is how tall the mountain is. This is a different meaning of altitude, not related to that. or we say the altitude of an airplane. This is just different. This is the distance from the horizon. Astronomers call it the altitude. So the altitude of the sun here looks like it's about maybe a little bit less than 15 degrees, and then it changes through the day. Okay, so you're learning some terminology. You can think about where the planets and stars are in relationship to the horizon, and the distance from the horizon is called its altitude. Okay, different, same word that altitude in different contexts, but different meaning. And these are good terms to know about. For example, what is the altitude of the zenith? You got it? The zenith, what's its altitude? By definition, it's 90. We would call it 90 north. And the altitude of the nadir is 90 degrees south. So altitude varies from 90 south to 90 north. What is the altitude of an object on the horizon? 0, by definition. Because it's on the horizon. If you're on the horizon, there's no distance from the horizon. Okay, so you're getting the idea of it. We're learning how the planets move through the actual sky and how what the terms are that are used to describe it. So I've discussed this, what the zenith is, what the nadir is. By the way, astrologers sometimes call the 10th house cusp, or they used to, I don't know if they still do, the zenith. That's wrong. If you've learned that, forget it. The 10th house cusp is not the zenith. The zenith is not usually used in the astrology chart. It's the point over your head. Because why is it not usually used? Because astrology focuses on the ecliptic plane. And the ecliptic plane is not going through the zenith. So if something's not on the ecliptic plane, we don't use it in astrology. How's that for a big rule? Okay? If something's not on the ecliptic plane, we're usually not interested in it. Or we make believe it's on the ecliptic plane. And I'll tell you I'll explain in more detail what I mean by make believe it's on the ecliptic plane. But notice the planets. The sun is always on the ecliptic plane by definition. Notice Mercury is close to the ecliptic plane. Ecliptic plane is this green thing, the path of the sun. Here's Mars, very close. Here's Moon, very close. Here's Jupiter, very close. Here's Saturn, very close. The planets are all very close to the ecliptic plane, and it makes it convenient to use it. Now, Pluto can vary quite a bit off the ecliptic plane, but remember, when these systems were devised in ancient times, they didn't know about Pluto. Well, here's Pluto, and it's pretty far off the ecliptic plane, very far off. The other planets would never get this far away from the ecliptic plane, and that's one reason why astronomers demoted Pluto, because it's not like a planet. One way it's not like a planet is that it goes way off the ecliptic plane, whereas the other planets stay very close to the ecliptic plane. They stay on this path, and it's convenient for astrology because we can just talk about how far the planets are from each other along this circle of the ecliptic plane. So the emphasis in astrology is on the ecliptic plane. And, for example, the Ascendant, the first house cusp, is where the ecliptic plane crosses the horizon. That point right there that I'm pointing to, right here. Here's the horizon. That's the Ascendant by definition. Where the ecliptic plane crosses this line, called the Meridian Plane. There's a circle that goes through the zenith and then south and north, cuts the sky in half from the rising to the setting. Where this plane crosses the ecliptic plane, what's that right here where I'm pointing? The ecliptic plane, that's the midheaven. And now you see why the houses are not the same size. Because we do everything on the ecliptic plane. Look how long this arc is. From here to here is longer than here to here. So these houses are going to be smaller. Right? So the ecliptic plane just moves all over the place. And it can get worse. So I'm going to go an hour. Now I went to click twice. Now the ecliptic plane looks kind of nice. Rises in the east, comes overhead, sets in the west. It's got a nice kind of symmetrical look to it. But later in the day, That happens when you have near zero Aries or zero Libra rising. Notice the constellation Virgo is there, but we don't use constellations. The constellation Virgo and the sign Libra are not the same. And I'll talk more about that probably in the next video. But I'm going to go an hour forward. I guess I clicked a few times there. Okay, now look at this. At this particular time of the day, the ecliptic plane is the ascendant is right here. The ecliptic plane crosses the horizon here. This is the ascendant. It's not due east. It's much further towards the south. It's 1/3 towards south. So what would you call that? Like east-east, south or something? Southeast-east, whatever. It's towards the south of east. And so the distance from the first house cusp, what's this? The 10th house cusp. Look at that distance as opposed to the distance from the 10th to the 7th. This is the descendant. This is the ascendant. This is the descendant. Look at the difference. So these houses are huge. This would be the 9th, 8th, 7th houses. 7, 8, 9 are going to be big, and then 10, 11, and 12 are going to be much smaller. And then how you divide these into thirds, well, that's what different house systems are all about. We're not going to get into that. I could make several videos just on how house systems are developed. But the angular houses are the same in most of the house systems, unless you use, whole sign houses or something. But the ascendant midheaven, well, they're used in almost all forms of astrology, even with whole sign houses. That's why the houses are not equal sized. Why? Because we use the ecliptic plane. What do we use in astrology? The ecliptic plane, for the most part. And we see where the ecliptic plane crosses other planes. Where it crosses the horizon is a big deal. That's the ascendant. Where it crosses the Meridian Plane, a big deal. That's the midheaven. So in collapsing this entire sphere of the sky onto a piece of paper, basically what we've done in astrology is put the ecliptic plane on the chart wheel. That's what we've done. We're looking at the ecliptic plane. The ecliptic plane is divided into 12 equal sections of zodiac signs. So when you put the houses on the ecliptic plane, they're going to vary size. You got it? So here's the chart wheel. What are we seeing around the outside? The ecliptic plane. And so that's why the houses change their size, is because the 10th house and the ascendant are not squared to each other. They're not 90 degrees. Because the ecliptic plane is not symmetrical. It's not symmetrical east and west. It's way up here and short, and it's real long. It's just the way the sky is. So we're looking at the ecliptic plane in astrology, and we're seeing where it crosses other planes. It's called the ecliptic plane, is the path of the sun. They're called planes because they're big circles. We call them great circles in astronomy. The great circle creates a plane. A great circle just means a circle with you in the middle. And the Meridian Plane, the horizon plane, and the ecliptic plane we've learned about. And we'll learn about two other planes. We'll learn a little bit more about this yellow one probably in the next lesson. Okay, so we're making a lot of progress, believe it or not. We now know what the zenith is. We know what the nadir is, the point. We know what altitude is. Altitude is the distance from the horizon measured directly to it. So direct distance, number of degrees above or below the horizon. Okay. The altitude of the zenith is 90 north. I explained that. The altitude of the nadir is 90 south by definition. Okay. Now, by the way, you can describe the position of anything in relationship to the horizon, right? It doesn't even have to be an object in outer space. You could just say, where is the door to your room in relationship to the horizon. If you have a light on the ceiling, it would end, and you could plot where that light is in the sky, what direction it's in. It would be above the horizon. If you were pointing to something on the floor, it would be below you. So you can plot anything. This is a way of measuring or plotting where things are in a sphere. Just like when you measure where things are in a room, you measure from one corner, a length, a distance, where it is along one wall, where it is along another wall. These are called coordinate systems, celestial coordinate systems, and a celestial coordinate system has a measurement along a circle. You pick a starting point, like you could start east. You pick a direction, you can measure in this direction, and then you have a distance from that circle. So if I'm measuring from 0 and along the horizon, and let me put this back. I've changed her. What did I do? I went all over the place. Let me go back to her birth time. I'll just do it an hour at a time. Okay, I'm back to her birth chart with the Mercury just above the horizon, the Sun here. So if I'm measuring 0 to 360 this way, where is her Sun? Her Sun would be almost 360, about 350 degrees, almost 15 degrees north. And this is called azimuth. It's a kind of strange word, but azimuth means you're using the horizon as your coordinate system. You pick a starting point, you pick a direction. There are different starting points in different directions, so there's not one agreed upon way to do it. But if I started here and I went in this direction, the Sun would be at 350 degrees azimuth and about 14 degrees north, just a little less than 15, it looks like, altitude. Because this circle's 15, 30, 45, 60, 75, 90. We just drew these circles every 15 degrees. So you get the idea. I can do one more. Venus, where would it be? I would project Venus, find the nearest spot, go directly as fast as I can. Most direct route would be about here somewhere. So that might be 10 degrees or whatever it is if I'm counting in this direction, and it's 15, 30, maybe 35 degrees or so. So it's about 35 north altitude, about 10 degrees azimuth. So you can plot any point, and that's what you do. You can measure in relationship to any we call these great circles. In astrology, we measure along the ecliptic plane. We don't usually measure along the horizon. We measure along the ecliptic plane. So you find a plane that you like. You can also call it a great circle. You find a great circle that you want to use. You pick a starting point and you pick a direction. So we use the ecliptic plane. Now, in Western astrology, what we call tropical astrology, what's the beginning point? Where are we going to start? A circle has no beginning or end. Where are we going to start? Well, this other plane that we talked about, called the Celestial Equator, where it intersects, means crosses this, becomes the beginning of the zodiac, 0 Aries. And the other one is going to be 0 Libra. So this one's 0 Libra, and this one happens to be 0 Aries. I'll tell you how I know that later. And it's also called the Vernal Equinox, because when the Sun, over the year, reaches this point, this exact point, that's when spring begins. And when it reaches this point, that's when fall begins. So you can visually know exactly to the second almost, when spring begins. To a second of time, you know when spring begins, because it's when the Sun gets to that exact point where this plane intersects that plane. Okay, so to make sure you got it and your head's not swimming, in astrology we measure along the ecliptic plane and we pick this kind of odd point. It's a little bit strange. It's not in relationship to the stars. It's where this other plane that I'll talk more about later, probably in the next part 3 of this, or maybe I'll get to it before we end. I'll talk more about this. What this yellow circle is called the Celestial Equator, where they intersect, defines the beginning of our zodiac. Okay. Now, let's go back to measuring along the horizon, because it's visually simple to think about. You know, it's your horizon. You can point to the horizon. I don't know where the ecliptic plane is right now. The thing moves around during the day. It's very difficult to know where it is. But we know where the horizon is. You know, it's sideways. It's horizontal from where you are. And we usually can find out where east is and west and so on. So I've got a question here. What is the approximate altitude of Madonna's Venus, Jupiter, and Saturn? How can we find out what it is? Well, we find out by looking at an azimuth altitude wheel. And instead of doing a chart wheel the way we usually do it in astrology, we could do a chart wheel in relationship to the horizon. You got the idea? In astrology, we use the ecliptic plane, which makes sense because the planets are along the ecliptic plane. But you can use any great circle. The ecliptic plane is one great circle. We can make a chart in relationship to the horizon, because these are just measuring systems. It's just a way of describing where something is. We can describe it in relationship to the horizon. And when we describe it in relationship to the horizon, we get an azimuth and the altitude. So, first question here is approximate altitude of Venus, Jupiter, Saturn. All right, what do you think? Here's Venus. Where'd it go? There it is. I just talked about that. What do you think its altitude is? 15, 30, maybe 35 to 40. Well, I think it's closer to, it's about a third through. I would think that's about 35, maybe even less. North, because we're above the horizon. Jupiter's over here, and we go direct to the horizon, and we go 15, 30, almost 45, maybe about 43 or so, south, got it, because we're below the horizon. And Saturn's over here, 15, 30, 45, 60, it looks like about 62, or something like that, south. So Saturn was fairly close to being underneath Madonna when she was born. When she was born, this was directly below her. Saturn was not that far from being below her. That we don't usually care about that in astrology, but it's an interesting observation. So, how do we know if our guess is very good? We'll do an azimuth altitude chart. Go to settings, and you have all these settings. You want tropical sidereal, what house system do you want? Nice thing about Sirius, it's all interactive. You select it and you see it. And here is the azimuth altitude. And actually we have 3 variations. Remember a little while ago I said there's no agreement about where to start azimuth. You can start at any point. Well, here's azimuth altitude with west on the left and south on the top. That's often used by astronomers, or navigators may use this. Not that great for astrological purposes. This horizon is nice because that's the way we do it, with east on the left, and it'll put south on the top, because the horizon is measured north, south, east, west along the horizon. And it'll put south on top and east on the left. And local space is nice because you can actually overlay the horizon chart on a map. And then this is done the way a map is, with west on the left and north on the top. But we're going to do horizon. They all tell you the same thing. They're just, it's like as if people couldn't decide where to put 12 o'clock on a clock. We put 12 o'clock at the top, but they couldn't decide. Some put it on the left, some put it on the right. They didn't know if they wanted the clock to go clockwise or counterclockwise. It's all the same thing. They just didn't agree about how to do it. So we'll do a horizon chart. and I'll say okay. It's removing the houses and so on because you don't usually want them in a horizon chart. So this is called a horizon chart. It's a way of doing azimuth altitude. The planets are roughly where they are in the regular birth chart, but not exactly. Sun in her birth chart is up here, now it's down here, and that's because in the sky, if we go back, the sun is in this direction. It's actually down a little bit north from east. But anyway, it's another representation of where the planets are. And if I right-click and I select a wheel style that has a lot of detail, this is a simple wheel, but I'll do this technical one, which means tons of information, and that'll probably have what I want. I'll click OK. And here's the altitude, and it's telling me that Venus is 34.5 north. Boy, we got good on that. We got a good guess on that one. So we said about 35, 15, 30, 35. And in fact, it is 34.5 north. Jupiter's 43 south, and Saturn's a little more than 64 south. So we got them all correct. Jupiter 43, Saturn 64. If you remember right, we said for Jupiter is here, 1530, a little bit less than 45, and there's the Saturn, more than 60, and it's whatever it is, it's 64 south. I thought maybe 62, 63, but it happens to be 64 south. So this is kind of nice. What we expect to see, we actually see. So you now know what an azimuth altitude chart is. And why would you select a horizon chart? Because it's got east on the left, just like we normally do in astrology. You put south on the top. We have to put south either on the top or bottom. We decided to put it on. It could go either way. It's just a matter of whether. Here we're measuring around this way, Aries, Taurus, around. And by the way, you don't really have Taurus or Gemini in a horizon chart. This would really just be 35 degrees, 57 minutes for Jupiter, but it's convenient to use the signs because it's easy to tell if they're aspecting each other. So if I was using degrees, this would be some crazy number of degrees, but now as 26 Scorpio, I know that it didn't really aspect Neptune. It's 15 degrees away from it, and these are all just crowded together to try to make them fit. So it's handy to convert them to zodiac positions, or I can look at this 7 Leo for Saturn, and I can say it's trine Sun, Mercury, and Moon at 5, 6, and 9 Aries. If it was in degrees, 127 degrees, 27 minutes, it'd be difficult to know that. So technically speaking, if you want to be really accurate in your terminology, this is really not Leo. There are no zodiac signs along the horizon, or maybe there are, but they're usually thought of as being along the ecliptic plane. But it's nice if your software will do that. We'll put them in zodiac position because it's easier to see the aspects. And when I selected this, one of the questions was, do I want it to show it this way? You have it asks you have the option to put it in degrees if you prefer it that way. Okay, so you should now be able to appreciate what a horizon chart is. It's looking at the planets in relationship to the horizon in what's called an azimuth altitude chart. Okay, so we know what the zenith is, we understand what altitude is, we know how to look at a sky map and approximate how far a planet is from the horizon and how close it is either towards the zenith or nadir. We guessed, we got them right. And we looked at an altitude azimuth chart, which I call the horizon chart in Sirius, a certain version of it. We have 3 different versions of it to see that. Now, and I explained this, local space chart is another variation of an azimuth altitude that has west on the left, just like a geographic map. I should maybe make a video someday on using the local space for picking directions. It's very cool. You can use Google Maps and overlay a chart on top of it. Very interesting stuff. I'll show you that sometime. Let's see. I'm not sure when, but if you want a video on something, just let me know, and I can do that. So all three of these different azimuth altitude charts are the same. They just have a different 0 point. The azimuth starts at a different point or goes in a different direction, either clockwise or counterclockwise. And I showed you how to see the altitude with that map. And now, getting close to answering our question. The moon's altitude is 4 south 21. Here's moon, 4 south 21. Mercury 0 north 37. Exactly what we expect. Moon is further from the horizon. Here's the moon. That happens to be 4 degrees, a little more than 4 degrees. This is less than half a degree. So the chart wheel is telling us exactly what we expect it to tell us just from visual inspection. Now, I'm not going to get to it in this video. I'm at a half hour already. It'll be in part 3. I promise, if you've been waiting for the answer to this question, you're probably getting tired of waiting for why Mercury, the big question, why, I'm going to go back to settings, coordinate system, normal. See, these are these questions. You want to remove house cusps, and let me go back to this big wheel. It's easier to look at. Why does Mercury look like it's 3 degrees from the ascendant and Moon 3 degrees from the ascendant? As if Mercury rose about 10 minutes ago and Moon rose about 15 minutes ago, when actually Mercury rose only 4 minutes ago, Moon almost a half hour earlier. Why can we not get it, approximate it more exactly? Why does 1 degree not equal 4 minutes? In fact, it gets worse. You can have a planet up here. You ready for this? You can have a planet up here in the 12th house, and it's actually below the horizon. Is that shocking or what? So you could have a planet in the first house, which we say is before rising, and it's already risen. And I'm going to show you that one of the first things in part 3. Okay, I'm going to end here. I'm at over 32 minutes, and we'll go to part 3. I think I'm probably finish this up in one more time. We'll see. Okay, namaste. Take care. Bye.